Have you ever noticed just how much fabric we use every single day? Or thought about how those fabrics impact our environment? Not all fabrics are created equal. Among textiles, there are pros and cons to each with lots of room for innovation. As concerns over the environment and shortages of raw materials increase, creative thinking about waste management takes on greater importance. This is where we come in. Our team at Oceanit creates cutting-edge technologies to solve real-world problems. Meet Tara, our senior engineer, taking the lead on this project. Recently, we've challenged ourselves with the question, what if we could revolutionize the world with chicken feathers?
The Department of Defense was looking for a new kind of material that would be sustainable and made out of a biological material as a replacement for textiles in military vehicles, like a seat cover, potentially even a seat belt.
So I'm sure you're wondering, why chicken feathers? We know that the world loves chowing on chicken. Just in the United States, an estimated 32.5 billion pounds of chicken are consumed every year. That's over 89 million pounds of chicken per day. That's a lot of chicken, and a lot of feathers. It is estimated that the US alone produces enough chicken feathers annually to fill more than 1 billion pillowcases. But unfortunately, chicken feathers are predominantly treated as waste because they are not well suited for purposes of human warmth and comfort like other feathers are. Every year, billions of tons of chicken feathers are disposed of. If left to decompose naturally, the process can take up to 5 to 7 years due to their protein-rich composition. I know that was a lot of startling information, but chicken feathers actually provide enormous opportunity.
Feathers are an amazing and robust material. In graduate school, I was studying all different types of bird feathers and came to be pretty impressed by the natural properties that feathers possess. Feathers are made out of keratin. There are a lot of other things in nature that are also made out of keratin. For example, horns, hooves. It's a very strong biopolymer. So the idea here is to keep a lot of the natural strength of the keratin and to use that in our textiles.
Keratin is extracted by grinding the feathers into a powder. We then add solutions to the powder and dry it in an oven so that it can undergo wet spinning, which is a process that the textile industry uses to create certain fibers. We have been researching various angles and methods to transform chicken feather waste into new and valuable resources. And like any breakthrough, there are many challenges and setbacks in our journey.
Feathers have been difficult to work with because they're really difficult to break down in a useful way. There's so many different things that are at play, like there's chemistry, thermodynamics, and the speed of how everything's moving. We're also trying to be safe about the whole thing and not use like very harsh chemicals, which does actually make things harder to get the same result.
But we are highly encouraged by our progress. Chicken feather fibers have the potential to replace plastics in many products. Global consumption of synthetic fibers amounts to 72 million tons annually. Imagine replacing some of these with a textile that could subtract from the current solid waste problem, reduce pollution to the environment, and overall, minimize our dependence on petroleum-based synthetic fibers. It could also serve as an alternate for natural textiles such as wool or cotton. Chicken feather clothing could be a mainstream textile of the future, and with further research, more robust fabrics could be derived, such as hiking harnesses and seatbelts.
The specific idea to make a textile is a pretty ambitious one, but this whole concept could be used to make other kinds of materials that are more efficiently and sustainably made and that are produced in the US, which is really rare to find these days. We're currently working on making a piece of fabric that is made out of those fibers. We've made a lot of progress. It's been a lot of work to get to this point, but it's very satisfying to make something very useful to the world.
While specific products and processes are still in developmental stages, future prospects are bright. We have a gold mine in this resource, and with further research, we could really make a difference.